Hello, my name is Miriam Isho. I'm in Math 132, and today I will be going over example 7 for my video project. So example 7 is split up into two problems, and we'll be going through the answers for those and also some concepts to keep in mind. So just a quick overview of what was covered in 2.2. The limit definition was used to find the limits of functions. So f prime of x equals limit as h goes to 0, f of x plus h minus f of x over h. And that limit definition will come in handy for our problem. And also, when graphing the derivative function, two things to keep in mind is that if a function is increasing, f prime has positive numbers. So if in the original function the slope is positive, then f prime will be above the x-axis because that's when your y values are positive and they're bigger than 0. And if a function is decreasing, f prime has negative numbers. So it would have to be drawn below the x-axis, and that is because the y values are less than 0 and they're all negative. So for the first problem, it says consider f of x equals 1 over x plus 5. Simplify using the derivative definition, which is, again, f of x plus h minus f of x over h. And so what this is really telling us is that you should plug in x plus h anywhere you see an x, and here plug in x for anywhere you see an x. So this is the function that we will be using, and for the first one we want to plug in x plus h anywhere we see an x. So here's our x, and we plugged in x plus h, and then we subtract it from f of x, which is basically just the function, which is 1 over x plus 5, and all of that would be divided by h. And for me to make things a little easier with simplifying later, I take the h from the bottom and take it up to the top, so it would become 1 over h. And then what I did was I found a common denominator to later combine the numerators. So since x plus h plus 5 was the least common denominator, I took what was missing from the other side and I multiplied it by the top and bottom. So what's missing from here was actually the h, and so I took h and I did h to the bottom and I times h by the top, and so I got x plus h plus 5 for both, and I have an h right here. And so then I combined the numerators since I have the common denominators, and I can do that, and I got 1 minus h over x plus h plus 5. And here, to factor out the h, that will allow us to have them canceled from the top and bottom. And so since it was negative on top, I'm taking the sign with it. And as we can see here, the h's cancel, that negative still remains, so it will go to the 1. And our final answer is negative 1 over x plus h plus 5. And since the question only tells us to simplify it, we really don't have to go any further and find the limit. But if we were to have to find the limit, then we would do limit as h goes to 0 and plug in 0 anywhere we see an h. And so since we have an h right here, that would be 0, so it would be negative 1 over x plus 5. But since we just have to simplify it using the definition, this will be the answer. The other question was a true and false question, and it states if y equals f of x is shown below on the left, which is in red right here, then y equals f prime of x is the graph on the right, which is right here in blue. So this would have to be the correct f prime graph of this function, but it is actually not, and so the answer to that is false. And here is why. So when we have to draw the derivative graph for any function, the first thing to look for is where the graph has any points that have slope of 0. So if we draw a tangent line right here and here, we can see that it is horizontal and it'll equal to 0. So when we have those, we know that in the derivative graph, they would have to be crossing the x-axis. And so here are zeros, 1 and 3. That's fine. But the main issue with this is that in this f of x function, if we draw more tangent lines along the function, all of those slopes would be negative. And so when you have a negative slope in the original function, the derivative function has to have it below the x-axis because that's where all of those values would be below 0 and smaller than 0. But the issue here is that it is drawn above the x-axis, which tells us that the original function had a positive slope, which is not true. So here is the actual f prime graph. This is a rough sketch of what it should look like. Here we have our zeros at x equals 0 and x equals 3, roughly. And since we have the negative slope right here, we drew our f prime function below the x-axis, indicating that the slope is smaller than 0 and it's negative. I hope this was helpful in reviewing section 2.2, and thank you for watching.